Let us look at proposition number 9 of book 6 of Euclid's Elements. The proposition says to cut a prescribed part of a given straight line. So basically what this means is we are given a line and we may be asked to cut a third of this line. So a third of this line would be somewhere here, or we could be asked to cut a fourth part, right? So how do we do that? That is what this proposition talks of. So let's see how the proposition not only cuts it into a third and but also proves the case. Now the first thing that the proposition says is to draw a line not on AB at some angle. That angle is not important. At some angle we draw a line starting from A. Then we mark a point, a random point on this line, D. And depending on how many, which part of AB we have to cut, that is whether a third of it or a fourth of it or a fifth of it, we mark points on this line equal to AD. So let's say we will do one thing. We'll mark or cut a third of AB. So which means we are going to create two more points on this line equal to AD. So we know how to do that. Let's hide the circle. Again, one more segment equal to AD. So now AD equal to DE equal to EC. Remember, we have to cut it into three parts, but what is required is only the one part of it. So now we join B and C and we draw a line through D parallel to BC. And let's mark the point of intersection. And let's join these points D and F and hide this line. Yes. So here DF is parallel to BC. Now in triangle ABC, we know BC, if it is parallel to DF, that means these are in proportion. AD is to DC equal to AF is to BF. We know that. Now we know that this is one part and this is three parts, or rather AC is 3 times AD. Since we are talking of AD is to DC, this is one part and this DC is two parts. So DC is equal to 2 times AD, which means what? FB is equal to 2 times A, which means AB is 3 times AF. Or in other words, AF is a third of AB, which is what we needed. So AF is the required part of AB. Okay, suppose we have to cut it into, or rather we want a quarter of AB. What do? We can actually continue here itself. There is no separate construction required. We just mark one more point of point C G equal to AD and we join GB, and at D or through D we draw a line parallel to BG on the point of intersection and draw this segment so that we can hide the line. And let's hide the circle as well. So let's hide these two. So again, and F is also not required. And again, these two are parallel lines. AD is to DC equal to AH is to HB. We know AG is 4 times AD. That means AD is 1/4 of AG, which means AH is 1/4 of AB. Yes. So that is proposition number 9 of book 6 of Euclid's Elements. Remember, there is a link to a PDF book in the video description which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now. Bye.